Good afternoon. Thank you for being here. My name is Jim White. I work for Amazon Web Services, and today we have the privilege of hearing from Arik from the New York Times. I'm sure we're all familiar with the New York Times. He's going to share a little bit of his implementation experience with his deployment of FSx for NetApp ONTAP. So without further ado, Arik, I'm going to turn it over to you.
Thank you. My name is Arik Chojnacki, and we migrated successfully a lot of SMB shares and NFS shares to FSx. So let's start from the beginning, So we have Windows shares, we have the NFS shares, and we have those shares on different platforms. We have on the iSalon, we have a Windows file servers, and we want to migrate this to data to FSx. So in this session, what I'm going to cover the Amazon FSx for NetApp ONTAP design and deployment, which is the critical component of the migration, consolidation and migration journey to FSx, benefits of migration, challenges, and if we have time, we're going to talk about I will have time for Q&A. So first of all, before we're going to start, what we have to know. First of all, we have to know our data. So we have to know a couple components. First of all, we have to know the utilization of each share, including to design the volumes. And what we have to also know about the data. We have to know the hot data and cold data. What is the hot data? Hot data, that's the data which is 30 days active. Last 30 days, this data have been written to our shares. And why? Because that will define our performance tier, SSD tier on FSx. And then we have to know also the cold data, which this data will be allocated later on our capacity tier. And we have to know also the type of the data. Why we have to know the type of the data? So we can predict the data reduction, including the deduplication and compression. From the data protection, we have to know our high availability. Do we need the HA? And in this case, we should implement the multi-AZ and FSx. Also, we have to know our definition and SLA for the recovery point objective to define the snapshot policy and backups and disaster recovery. If any of the volumes, all the data require the disaster recovery, that will be our candidate to replicate between regions. For purpose of this session, I will review all migration steps for imaginary project. And starting our project, we will collect the data from current environment. And let's say we have 9 shares, approximately from S1 to S9. We collect the data, we identify the hot data, so data which is less than 30 days. And we also will collect how much we have the cold data. How to get the information? If you're going to ask anybody, then everybody will say, yeah, all my data is active. But if you have the third-party software, tools, you have the PowerShell, RoboCopy, you can identify that from the 100% of the data, maybe 10% to 20% is the hot data. So we have 9 shares. And with 9 shares, those shares, belongs to 3 departments. Department 1, Department 3, and Department 2. From HA, we need HA for each share but we don't need the R for each share. For example, the S1, it's our ISO images, etc. We don't need them to be replicated. And from the RPO and hours, we see the different requirement from each department, from each share, from 24 hours to 1 hour. So let's group all shares by attributes and define the volumes capacity, because this is very important. Remember that from the snapshot policy, backup policy, everything is based per volume, not per share. So the volume size, how we will basically design the volumes, will contain the data size, plus we will add the reserve capacity for the snapshot. In my example, I like to reserve 20% of the capacity dedicated for the snapshots. And let's say we're expecting that growth per year around 20%. And for the auto growth, because we can set up the auto growth per volume, we estimated that we should not expect the growth over 150%. So based on the grouping of those shares, we came out to this conclusion that we will create 5 volumes based on the current utilization. So we can combine everything. We have also the volume size, snapshots, 20% growth, and then we have the volume size in gigabytes. So as you can see, we will have the volumes from 140 gigabytes to 5 terabytes. But what is very important, during the migration, the data flow when we write the data to the FSX. From the source data, we're writing all the time the data on the first step, first wave, to SSD. And then in SSD, we have the deduplication and compression, and then we can move the data to capacity tier. So for example, if we have 1 terabyte of data, and we want to set up the auto-tiering, automatically go everything to the S3, then everything first has to land on the SSD, and then move to the capacity tier. So the critical component of the FSX, it's SSD, which is the performance tier. If we don't design this SSD tier correctly, we can face probability that we will be able to write to FSX, because all the SSD tier will be overwhelmed. So what is the algorithm? During all those migration, I came up with the algorithm, which actually it's very accurate, and we don't have to actually extend the SSD tier for very, very long time. So first of all, we have the largest set of data which we want to migrate to FSX, and we anticipate that this data will land in first step in an SSD tier to do the duplication and compression. Then we have the sum of all the hot data from all our volumes. And SSD size should be all the hot data plus 50%, because what's happened is with the auto-tiering, when we have the SSD, then the first data is going to SSD, and we should have the 50% available after we will write all those hot data. Because the algorithm of the auto-tiering will trigger the movement of the data from the SSD to capacity tier based on our auto-tiering policy, and also the SSD has to exceed 51%. Then, when we do the backup, or we are moving the data, then with the storage efficiency, we have to have space to actually make sure that the SSD will handle the amount of the data which we will be putting on the FSX. With the backup, we have exactly the same situation. The backup is a little bit different because if we want to restore from the backup, it's on the back end, so the data flow is much, much faster, and we can overload the SSD tier. So this is critical. If we have the SSD and we have the set up correctly, then we're not going to see the spike over 70 to 80% of utilization of SSD. So at this point, based on all the situation scenario, we are configuring our FSX for NetApp ONTAP in 2 regions. Our production in our region 2 with the multi-AZ SSD based on our calculation. We have the 5 volumes. Then we have the replication to region 2. But for the region 2, because that will be our target, we don't have to do the multi-AZ. We can do single AZ, so we can save money on the SSD tier. So first, we have to build based on the design, we are building the FSX. We have the SSD, so we define the SSD. We have our volumes. We do with the flex volumes. We enable storage efficiency. And default volume during the migration, it's all. So everything should go directly to S3. Why we want to use at this point, SSD tier? We want to use the SSD tier only for the data efficiency. Then we create all those volumes. At this point, we are not creating the snapshots. We are doing the migration. So after we finish initial copy, initial sync, then we're going to start doing the snapshot. On the beginning, we don't need to. Then, with the migration steps. So when we set up the storage efficiency, all going to S3, we have the SSD performance tier set it up. Then right now we are starting the sync. The initial sync, at this point, we can use any software which we want to. We can use the rsync, we can use the RoboCopy, we can use the third-party software, and then we can also use the RoboCopy for Windows, and we have to finish the initial copy. Then when we finish the initial copy, then what we have to do, we have to enable the auto-tiering. Why we have to enable the auto-tiering? We have all data in S3. Right now we want to put all the hot data, the delta, to SSD. So our hot data will be in SSD. So at this point, when we start doing this, the old hot data will land in the SSD, and we'll wait until 30 days, for example, and then they will be moved to the capacity tier. Also, at this point, we will start doing the snapshots because we want to have the snapshots. Also, very nice thing with the snapshots, the FSX snapshots, for example, with Windows, it's integrated with the shadow copy, so you can see the shadow copy in your Windows. And after initial copy, what we already did, and we want to set up the backup. The backup, it's set up a little bit, tricky, because, excuse me, you set up the backup based on the FSX, not based per volume. So the backup is the global settings for your FSX. If you have different requirement, then you should use the AWS backup, or you can set up more than one FSXs. Then we have to also set up the replication between source and target. For this particular exercise, I'm really recommending using the BlueXP because it's very easy to set this up. The cutover. Cutover is the most painful, I will say, task. So first of all, if you have the global namespace like the DFSN, then you have the ability to actually cut over individual shares, not the whole volume. Otherwise, if you are using CNAME, then it's a little bit tricky. If you want to schedule the cutover, you need to have the time of sync for the delta from last 24 hours. So you can automatically estimate how much downtime you're going to introduce during the cutover. And before start syncing the last delta, then I'm recommending to set up the source to read-only, sync the data, and then you can cut over and do the read-write. And benefits of migration, what we did. We eliminate complexity of our current solution, managing NAS, Windows file servers, etc. Right now we have everything under one pane of glass. We also optimize cost of SMB and FSx shares in AWS. After migration from all our solutions, which we have on-prem and in AWS, our cost has been reduced approximately around 70%. And why? Because we introduced the duplication and compression, and with the auto-tiering cost of the S3, it's much more or less compared if you have to put everything on the SSD. So in this small comparison, I want to compare Windows file servers. If you will migrate the Windows file server with all those shares which we have to NetApps. So as you can see, in our scenario, from 9 servers, because we need the HA between AZ1 and AZ2, then we need also another set in the West region. So and from the EC2 instances point of view, we shrink from 9 to 4. And so savings is 5 cost of the 5 EC2 instances. As you can see, it's significant. Then EBS volumes. Remember, one thing with the FSx is that it's thin provisioning. On EBS volumes, you have thick provisioning. So if you have any solution with the thick provisioning, you are paying a lot of money, not for the utilization of the storage, but for the provision storage. And S3, we don't have the S3 on the another solution because they don't support S3. With the FSx, because support S3, we add cost of the 15, for example, 15 terabytes of the S3, but it's significantly lower compared to the EBS volumes. Our challenges. So design of the volume, it's tricky. And you cannot find golden rule. But what you have to look, you have to know your data, and based on your data, you can actually group all those, shares, and then create the volumes based on the requirement, RPO, RTO, and snapshots and backup requirement. And capacity of the SSD, of the performance tier, it's critical. And the most important thing is coordinating with the stakeholders. It's very difficult many times, and everybody knows why. Everybody, they don't have the ability to introduce any downtime during the production hours, so it's very difficult actually to find out the golden time. And set up appropriate monitoring, which is critical. Utilization of the performance tier, it's critical, and we should know if it's up to 70%, that will be warning. 90%, this is alarm, and you have to react right away. CPU utilization, yes, we should check it out, the CPU utilization, especially if moving transit data, then perhaps we have to also resize the CPU because of the number of the data which we are pushing into FSX, and latency, which is very important for us too. And what we like about FSX for ONTAP, high availability in the regions, AZ and AZ1, AZ2. And we don't have to, worry about anything. Auto-tiering, deduplication and compression, integration with Windows DFSN, DR between the regions. It's very, very good. Ransomware protection, snapshots integrated with Windows previous version, Windows ACL, scalable performance encrypted at rest, and multi-protocol. And just summary of the session. First of all, you must know your data. You have to take all variables into consideration to meet SLA, especially from point of view of the RPO and RTO. Use BlueXP to manage your FSX environment. Also, check it out, ransomware protection. This is very important. Today was a very good session regarding the ransomware protection in the morning. And attend all FSX session to better understand FSX under the hood. My time is up, I'm sorry, thank you so much, and have a nice AWS and reInvent, and I recommend to attend all those sessions about the FSX because for us, it's a great product. Thank you.